The person behind the wheel, bad day or good? Distracted or paying attention? Heavy traffic or a smooth commute? Car operating normally or is something amiss? How is a driver's performance affected by other mental and physical tasks and stresses? Can sophisticated technology in vehicles help detect these situations? A team of researchers led by the Texas A&M Transportation Institute recently explored these questions as part of a project sponsored by the Toyota Class Action Settlement Safety Research and Education Program. The team included researchers from TTI, Texas A&M University Industrial Engineering, Mechanical Engineering, Industrial Distribution and Engineering Technology, the University of Houston Computational Physiology Lab, and the University of Michigan Transportation Research Institute. The first phase of driver testing was conducted in TTI's driving simulator and at Texas A&M University's Rellis campus. Subjects drove while texting or mentally solving math problems.
916. That's incorrect. Please start back from 1020.
Reactions were recorded using galvanic skin response, a measurement of electrical activity of the skin, and subtle increases in perspiration. A heart and breathing monitor was another stress measure. The purpose?
The purpose of this study is to see if we can detect online problematic driver states, cognitive states. So high stress levels, high workload levels, if they're doing something they shouldn't at the same time as driving, like texting, or if they're emotionally really, supercharged, and that can be problematic for driver behavior.
When we face challenges or danger, we instantaneously perspire around the nose. And we managed to develop a method to capture this using thermal imaging and mathematical modeling. So by monitoring this variable, we understand at every point in time what's the internal state of the driver. And then we're trying to associate this with his or her performance.
We can detect driver stress levels in real time, and when we determine a driver is in an overstressed state, we can begin to do things to the vehicle itself to make driving easier for the driver and get those stress levels back down to normal. Our system begins to look at the thermal imagery of the face, basically how warm and cold certain areas of the face are, and use that as a stress indicator. Once we determine you're in that overstressed state, then the vehicle provides a piece of information to the driver that lets them know they need to start to calm down as a driver and get their stress back to a real level that's safe for driving.
The Phase 1 goal was to reliably measure driver physiological and performance responses to high cognitive, emotional, and sensory motoric stress to determine how drivers respond physically to these stressors. Phase 1 then moved to the test track, where the same analytic techniques were applied to drivers behind the wheel of TTI's instrumented vehicle.
We have a very sophisticated data collection system that's been installed, and so it's got precision GPS, it's got integrated computers that collect all sorts of physiological data that we need to do. It can collect driver performance data, what's going on with the steering wheel and the throttle and brake. So it's going to give us a wealth of data from a real vehicle, real environment that we should get a lot of use out of.
Phase 2 introduced a new variable. Half of the simulator test participants were presented with an indicator light that let them know when they were becoming stressed. The light, located on the steering wheel, illuminated red if stress levels exceeded a preset threshold. Participants were taught a deep breathing technique to lower their stress levels.
I enjoyed playing with the light, so to speak, being able to actually just calm down and stop what I was doing and maintain the safe drive, but still bring my own stress down.
When you gave me the math question, it seemed simple, but it was still very distracting. And so when I couldn't get it right, it distracted me even more. And then when the sensor started going off, I realized how stressed I was and how disengaged I was from actually driving.
I'd like to see it projected up on the inside of the windshield, maybe something, just a light that says, you're stressing, don't you want to calm down? And then I could practice my breathing. I am also known to just let it all out in a flurry of cursing.
While most of the stress participants' experiences involved distracting mental or physical tasks, another unexpected event occurred toward the end of each driver's simulator or test track session: an unintended vehicle acceleration. This surprise acceleration, controlled by experimenters, was an opportunity to see how drivers dealt with this stress-inducing situation. In a parallel effort, project researchers worked to develop techniques for detecting abnormal vehicle operations, like unintended acceleration.
We were able to develop fairly effective algorithms that can detect unintended acceleration in real traffic, can differentiate between unintended acceleration that is caused by a vehicle malfunction versus a driver misbehavior, and have a mitigating scheme that can be potentially implemented on a production vehicle. The core part of the algorithms are effective in being able to detect a variety of anomalies, not just unintended acceleration, but also occurrence of lane changes that may be inappropriate to the given traffic situation.
So for example, if the vehicle senses that steering is out in an abnormal state, basically there's too much steering wheel deviation, that's an indicator of a high stress state. The vehicle can then, if we wanted to in the future, have that vehicle begin to maintain lane position a little bit better for the driver, so we're actually reducing the risk.
Cars are getting incredibly smart, and the added electronics is making it possible for vehicles to have these added features, but each one of these added features also introduces the possibility of something potentially going wrong. And so you need to have this added surveillance system that effectively monitors the behavior of the vehicle and properly inform the driver, or potentially take a mitigating action when necessary.
One of the big advantages of the results of this project is that we are finding out that now the driver and the vehicle are going to share a certain responsibility, a certain partnership in this quest for safer driving. The driver is being sensed by the vehicle continually to determine if they're in an overstressed state, and if they are, the vehicle can step in and warn the driver and say, okay, things are getting out of hand for you, but the vehicle can also step in and say, yes, I need to do something as well to make it easier. Now the other dance partner is the driver. That driver always, and we have been doing so for many years, sensing the vehicle and making sure that it is in a good state for safe driving. Now we have this really intimate partnership between the driver and the vehicle, which we are augmenting with information through the project. The fact that we can sense the driver more easily, and the fact that we can make changes to the vehicle.